Hello everyone, welcome back to another video about Azure. So today's video I will discuss about using Azure Monitoring Workspace for AKS monitoring. So Azure Monitoring Workspace is a relatively new service which will allow us to monitor cloud-native containerized application. So it will help us to improve our observability in containerized environment. So let's take a look at what is Azure Monitor Workspace, and we will see what are the benefits from integrating Azure Kubernetes Service with Azure Monitor Workspace and the architecture behind it, and we will see a demo as well which will use Azure Monitor Workspace in AKS. So what is Azure Monitor Workspace? So Azure Monitor Workspace is basically a managed service which is built from the open source tool Prometheus. So if you are familiar with cloud-native monitoring and Kubernetes monitoring, then you will already aware about Prometheus. So it is one of the earliest projects that are managed by CNCF. So it has very extended users. So they lot of organizations and DevOps practice will use Prometheus for de facto monitoring for cloud native and containerized application. So Azure also has a service, managed service, which will use this Prometheus to collect metrics from your AKS monitoring and the container monitoring tool, so you can have a better visibility about your application and you can improve your observability in your cloud native application, and especially in containerized and Kubernetes. So as I mentioned, so Azure Monitor Workspace aka Prometheus is a fully managed service, so you don't have to implement complex availability and storage related components. So it is fully managed service which is available in Azure. At the moment, Azure Monitor Workspace is only supporting Prometheus metrics, and you can integrate Azure Prometheus Azure Monitor Workspace with another very popular open source tool which is Grafana. So Azure also has a managed Grafana solution which will use Prometheus as a data source, and you can visualize very insightful and meaningful dashboard through Grafana. Okay, let's take a look at high level architecture about of Azure Monitor Workspace. So usually when you come to the Azure Monitor metrics, there are few metric types such as native metrics, like platform related metrics, and if you are building your custom metrics, then you can import those metrics into the Azure Monitor Workspace. So platform related metrics means actually, for example, if you have Azure Kubernetes cluster, then that Kubernetes cluster platform level, there are some metrics are exposed from itself. So for example, cluster related CPU, node CPUs, those kind of things. Then if you have any Azure Monitor agents are installed or application insight is using, and then you can build your own custom metrics for your application, then you can ingest those metrics into the Azure Monitor as Azure Monitor metrics. So then You can view those metrics through the workbooks, dashboards, and metric explorers. And if you want to notify those, then you can use Azure Metric Alerts to notify those. But when it comes to the Azure Monitor Workspace using Prometheus, right? So as you can see here, so it is a specially created Azure Monitor Workspace. So it only supports Prometheus metrics at the moment. So what you can do is you can connect your Kubernetes clusters with Azure Monitor Workspace. Then in Kubernetes clusters, you have metrics agents that collect Prometheus metrics that is exposed from different components in your cluster. For example, your nodes will have Prometheus metric exposed, then your control planes, then all the pods that are running may have Prometheus exposed, so metric exposed, or in Azure Monitoring Agent has an option to collect those Prometheus metrics from your workloads running in the cluster, then send those metrics to this Prometheus database, that is Azure Monitor Workspace. So Prometheus is actually using time series database. It's a very special kind of database. So it is specifically, that database type is specifically designed for metrics. Then when you send these metrics into the Azure Prometheus Workspace or the Azure Monitor Workspace, then you can use tools like Grafana, then the PromQL to query those metrics and build insightful information. Then you can use Grafana to visualize those metrics in meaningful dashboards. Then we can use Prometheus alerting tool to generate alerts based on threshold and notify if there are any incidents or if there are any anomalies happening in your cluster. So what are some benefits we can take from Azure Monitor Workspace? Basically, if you're already familiar with managing Prometheus in a self-hosted way, it is not easy actually, because you need to make sure your Prometheus pods are running properly. Then you have to configure your node exporters. Then you need to configure the storage, then the high availability, then the security, then metrics collections. Then there are a lot of components we need to consider. But as a managed service from Azure Monitor Workspace is very scalable, because if you are using self-hosted, if your environment is if your environment is growing, then you need to think about scalability. How can I scale my self-hosted Prometheus environment? But by using managed service, this scalability will be automatically handled by the cloud provider, so you can use it very easily. And as a managed service, it is very easy for us to deploy. You don't have to do a lot of configurations, easily integrate with the Kubernetes as well. So that's what easy configuration means. So you don't have to do a lot of configurations. By integrating workspace with the cluster, will export metrics into the Azure Monitor Workspace. So typically within a very short period of time, you can build up a monitoring solution or observability solution for your container workloads which are running on AKS cluster. But with the managed service, there are some limitations are coming, because when you're using self-hosted, you can do a lot of configuration and customization. But when you're using managed service, there are some components or some settings that you cannot, there are settings there are you cannot do, and you cannot do a lot of customizations. So these are few limitations. The minimum frequency for scraping and storing metrics is 1 second. That means you cannot go lower than 1 second for scraping the metrics. So scraping means actually Prometheus is a pull base. So that means Prometheus will talk to the endpoint of the agents and scrape the metrics from there, right? So if you put the scraping interval to 1 second, that means every 1 second the Prometheus will get the latest metrics. So when you do the node updates, you may experience gaps, which will last for like 1 to 2 minutes, because when you are doing cluster node updates, then there will be the agents will be not unavailable, so you may see some metrics gaps between those. Another limitation is manage Prometheus for Windows node isn't automatically enabled. So if you want to monitor your Windows nodes in the AKS cluster, this is not automatically enabled. It's still in preview. So you have to manually enable it and use it. Okay, now we have some idea about Prometheus and Azure Monitor Workspace. So let's take a look at how we can work with Azure Kubernetes Service and Azure Monitor Workspace. So in this demo, I will share you how we can create a cluster with Azure Monitor Workspace, then how we can create a Azure Managed Grafana environment and connect the Azure Monitor Workspace and Grafana, and we will see dashboards within the Grafana to view these metrics. Then finally we will see how the Prometheus alerting rules works as well. In this demo, we are going to take a look at how we can provision Azure Monitor Workspace into Azure through Azure Bicep. So you can do this same thing using Portal as well as using Azure CLI. I will put down the links in Microsoft documentation, which will show you how to do this deployment through the CLIO portal. But for this one, I will use Bicep because it is much more easier to automate the provisioning. So I will share this Bicep template with you all in the GitHub. So now we have the Bicep template. So we will take a look at what we discussed in the introduction. What are the components that we are going to provision for creating a Azure Monitor Workspace with Azure Kubernetes for monitoring, right? So if I explain in my Bicep template, so we have some parameters, right? So like location, then you have the cluster name, then the recording rules, names, and user ID. This user ID is uh, the Active Directory user ID that will use to give permission to role assignments in the Grafana and Prometheus. The first resource we are going to create is our managed cluster, AKS managed cluster. So this managed cluster contain different configurations, but the most important configuration when you're working with Azure Monitor Workspace is under the Azure Monitor profiles, you can find the metric settings. So this metrics, if you enable this metric configuration, if you make it through, then you should have a existing Azure Monitor Workspace, or if you didn't specify the workspace, then Azure will create a default Azure Monitor workspace to connect this cluster into the Azure Monitor Workspace. So this is one of the main key configuration that need to be configured when you are working with Azure Monitor Workspace. Additionally, I have enabled the container insights with log analytic workspace. So all the logs from the AKS will send to the log analytics workspace. Other than that, I have enabled the add-on for OMS agent. Then I have a basic agent pool profile and Linux profile as well with the public key. Then the second resource that we are going to create is our locality workspace. As you can see in the Kubernetes bicep, this locality workspace will use to use uh, container insights to send logs and or other components for analyzing and logging purpose. Then we are having Grafana workspace created. So this is a Azure managed Grafana service. So this Grafana will allow us to view Prometheus metrics because Azure Monitor Workspace is a managed Prometheus service offering from Azure. Therefore, Grafana can be used to view those dashboards and metrics from the Prometheus. So here you can see under the properties of the Grafana, we are doing our Azure Monitor Workspace integration. Then we are providing our Prometheus resource ID to connect with Grafana. Then we are creating our Azure Monitor Workspace. So I didn't put any additional configuration, but you can refer like additional configure like networking and all the other configurations that are need to configure for enterprise level security aspect, right? But for this demo, I didn't do those things. I basically created the Azure Monitor Workspace and connected with the Grafana. Then when you use Azure Monitor Workspace, uh, it use data collection endpoints and data collection rules and data collection association to connect those three components and send relevant metrics to Azure Monitor Workspace. So first we will create a data collection endpoint. When you're creating these data collection endpoints, you have to make sure that this name should start from MS from for to identify it as for the Prometheus, right? Then I will use data collection rule in here. In this rule, I am specifying the data collection endpoint, which used to ingest data into the uh, Prometheus. Then under Prometheus forwarders, I will specify the name, then the stream. These should be the same name. So these are predefined names, stream names that are used for Prometheus. Then the destination section, we will specify our Azure Monitor Workspace account name. Then the account resource ID, I will specify my resource ID for Azure Monitor Workspace. Under the data flow, we can specify what type of data you are going to ingest into the Azure Monitor Workspace. In this case, at the moment, Azure Monitor Workspace only supporting Prometheus metrics. So therefore, I will put Microsoft Dash Prometheus metrics. So it will send all the Prometheus metrics into the Azure Monitor Workspace. Then I will use data collection as rule association. So this will combine data collection rule and with your AKS cluster. So then the AKS cluster can send that specific metrics through the data collection rule and through the data collection endpoint to Azure Monitor Workspace. Then I have specified few inbuilt roles such as data reader role and Grafana admin role, then the monitoring metric publisher role, and I have created few role assignments as well. So, for example, this role assignment is very important, monitoring reader role assignment. This will allow Prometheus to uh, Grafana to read metrics from Prometheus and view those metrics in the Grafana workspace, right? So then the data reader will also use to uh, allow us to read the data from Grafana workspace, sorry, Azure Monitor workspace. Then this Grafana admin role assignment will allow the user, whoever who's provisioning, or if you have a group, then you can specify the user ID of that group. Then that group or the user will get the permission to admin rights to the Grafana uh, workspace in Azure. Then we have some recording rules. If you are familiar with Prometheus, you will know about recording rules in Prometheus. These are kind of a predefined rules that will use to collect uh, specific query data. Then those recording rules will store these results. So every time we will reduce the number of querying to the Prometheus. So you can use these recording rules to get specific metrics and data from Azure Monitor Workspace to show them in the dashboard and that kind of thing. So you can create your own recording rules here. So I have multiple recording rules already created. So you can see like CPU counts, then CPU utilizations, then the node loads, likewise memory related recording rules are created. Then I have another set of recording rules, right? So these set of recording rules used for get the metrics from workloads of the Kubernetes like pods, then the containers and those kind of container related memories. So workload related metrics will specify in this uh, second recording rule. The first one has the node level and cluster level metrics. Then I have created a few. Then there's another recording rules set which used to uh, gather data or the metrics to show them in the Azure portal. So these recording rules will help you to show overall view about the cluster in Azure portal. Under the AKS cluster, there's a section called Insight. So in the Insight, if you can get the overall idea about the cluster and the cluster status. So those metrics will collected from this UX Prometheus recording rule set. So I will show you them when I provision the cluster for you. Then again, I have created uh, another set of recording rules. So this recording rules set will use to yeah, there's another set of recording rules. These recording rules is actually these are not record is a type of recording rules, but what we use these rules to create alerts in the Azure Manage Prometheus Azure Manage uh, Monitor Workspace, right? So these are few of these alert rules. So I have created. So these alert rules will always check the expression. For example, if you want to see any uh, pods are crash back loop backing, then you can use this expression to uh, query those query the Azure Monitor Workspace and get the results, and based on that you can create an alert. So that's what these alert rules are doing. So this will check every 15 minutes and you will put the severity warning. Then I'm enabling the alert. Then you can make it auto resolve. That means if the pod crash back stop, then it will automatically resolve the alert for you. Then you can specify the time you are allowing to resolve the specific alert. Then I am using action group. So this action group also configured in top. So you can see this action group is created. This action group will send an email to this email address, right? So then you can get notified when there's something is wrong in your cluster, right? There are other options available in action groups. For the simplicity, I use the email, but you can trigger a webhook, or you can integrate with your ITSM systems, or you can run like a logic app or any other. There are multiple options that you can configure in action groups. So there are a lot of few alert rules are created here. So you can find these example alert rules in the by searching the uh, internet. So there are a lot of examples you can use. Okay. Now you have some idea about what are the resources that we are going to provision. So now let's take a look at how we can provision this one. So I have created a few commands for this. So what I'll do is I will create a resource group first. Then I will create the resource. Okay, now you can see the biceps is starting to deploy the cluster. So this will take few minutes. So after this is finished, I will come back and we will go through in the Azure portal and see how it's work. Okay, now you can see that all the components related to the Azure Monitor Workspace and AKS are created. This included the resources such as Azure AKS cluster, then the Azure Monitor Workspace, then the Grafana workspace, then as well as all the recording rules and the Azure uh, action groups to notify. Those all the components are created in here. So now let's take a look at these resources in Azure portal and we'll verify that the components are properly deployed. So now I have logged into my Azure portal. Then if I go to my resource groups, then I have a resource group called AKS Mon, then the random number with the RG. Then here you can see all the resources that are uh, provisioned through the bicep template. So here you can see the AKS cluster, then Azure Managed Grafana, then the Logatic Workspace, then the Azure Monitor Workspace, and the alert rules, and the data collection endpoint, and as well as um, other recording rules, Prometheus rule groups are already there, right? So first we'll see uh, in the portal how the AKS and Azure Managed Workspace is going to communicate, right? So for example, if I go to the Azure Mon cluster Prometheus Azure Monitor Workspace, then here you can see under the Manage Prometheus, then the Monitor cluster. So if you go to this monitor cluster, then you can see that the cluster that I provisioned is integrated with the Azure Monitor Workspace. So this will use the data collection rule and data collection endpoints to send the metrics to this Azure Monitor Workspace, right? Then under the rules group, you can see all the alert rules as well as recording rules that we configured in the bicep. So these rules will use for Prometheus alerting and dashboarding purpose. Then if you go to the data collection endpoints, you can see there are two data collection endpoints. One is created for your Prometheus and other one is automatically created there, right? So then if you go to Prometheus exporters, then you can see Prometheus Explorer, you can see the status of your components. Like if you put up, then it will show you all the monitoring components are up or down, right? Here you can do is what you can do is you can use PromQL, that is the querying language of Prometheus, to write your own queries. Then you can see the results in here as well. Then next we'll see Azure Manage Grafana. Then if you go to Azure Manage Grafana, then under the integrations, you can see Azure Monitor Workspace. So you can see that my Azure Monitor Workspace is integrated into the Azure Grafana. So when you log into the Azure Grafana, you can see Azure Monitor Workspace as a data source in Grafana for your dashboards and other querying purpose. So In the explanation of the bicep, I have mentioned you that there are some UX recording rules which use which are used for Azure AKS cluster insight. So let's go into the AKS cluster. Then if you go to the insight section of the AKS cluster under the monitoring, then here you can see overview of your uh, cluster. For example, you can see the events, warning events, and total events. Then you can see how many nodes are running in the cluster. Then what namespaces are using CPUs. Then how many pods, number of pods. Then the node CPU count, node memory. Then the namespace memory utilization, as well as warning events divided by the reasons, then the logging events and all the other networking related and AKS managed infrastructure metrics also available in this overview dashboard. Then under the nodes also you can dive into the different nodes level metrics as well. So you can see in here this each bar is representing the 2 minutes memory metrics usage, right? So here on the top you can see like which metrics do you want to see, like CPU, memory related metrics. And under the controllers, you can see different controllers like daemon sets, the replica set or deployment, replica sets and daemon set related metrics also presented here. Then under the containers, you can see individual containers level, how much of resources are used in these individual containers. So this will help you to identify if there are any high consuming containers in your environment. Okay, so now we have some idea about how these um, monitoring is Azure Manage Prometheus Manage Workspace Monitor Workspace works. So let's go and see some dashboards in Azure Manage Grafana. So I will go to the Azure Manage Grafana, then there's an endpoint URL here. So you can click this endpoint URL, then it will open to the separate window. Then I will use my login to log into the uh, Grafana dashboard. Then when you log into the Grafana dashboard, you can see these dashboards under the dashboard section. Then you can see Azure Manage Prometheus. There are a lot of pre-populated dashboards available for you to use. Otherwise, you can always import other Grafana dashboard based on your workload needs. So if you want to export specific dashboard, then that's also possible. So let's take a look at one of these dashboard. For example, if I go to the cluster resource dashboard, if you click that one, then you will see the cluster-wide resources utilization, right? So you have to make you have to you may notice that under the data source you can see the our managed Prometheus data source is automatically selected. Then you can see the cluster that we are going to use. So that means one single Azure Monitor workspace can have multiple clusters connected. So if you have multiple clusters connected to one single workspace, then you can select drop from this drop down. You can select that specific uh, work cluster, as well as you can connect multiple Azure Monitor workspaces into one single Grafana as well. Then you can from here you can drop down and select the correct data sources connected to the Grafana. So in this dashboard, you can see the overall usage of the cluster, right? So you can select the time zone. Yeah, default time zone. Then you can see how much of your CPU utilization, if you are there any request commitments, limit commitments, and memory utilizations. And you can see them in namespace wise. Then you can see the memory also in the namespace wise. Then network related metrics also visible here. So these are some very important metrics like storage related throughput, IOPS metrics are also available there. Then we'll take a look at another dashboard like this pod namespace pod dashboard. So then if I select namespace which has containers, you can see the different metrics like CPU metrics related to individual pods. Then you can see the list of these pods in table wise. Then graph, you can see a memory and table. Then the network related metrics for each of these pods are also there. So these are very important metrics can use when you want to get some insight or do troubleshooting in the AKS. Then the namespace workload also like that. So if you select a specific namespace, you can see different network related and memory and CPU related metrics. So if you go to if you want to see the kubelet related metrics, you can select the kubelet related dashboard. Then it will show you how many running kubelets are there because there are three kubelets are running because we have three nodes that each of these node has their own kubelet. So then you can see the kubelet related metrics as well, like how many containers are running in these kubelets, how many containers are managing these kubelets, then the reports count, then all the other uh, metrics related to kubelet will show in this dashboard. Then additionally, you can see like cluster related, network related dashboard. There are multiple network related dashboards as well. So let's take a look at the cluster network, right? So you can see uh, individual node wise, so you can select all the nodes as well. So you can see max egress, minimum egress bytes. So any packets are dropped when the transmission is going on. Then interface level metrics also there. If you go to node exporter also, you can see node exporter level metrics as well. So you can see each and every node, how much of disk space is using in the node, like memory usage, actual memory usage, and load average. And those are very important metrics as well. Okay, let's assume that you need to import a dashboard from the Grafana uh, marketplace. That's also possible. So if you search for Azure Kubernetes dashboards for Grafana, then if you go to all dashboards, then if you search for Kubernetes, like this dashboard is very detailed. So for example, we can use this dashboard. What you have to do is you can copy the ID of this dashboard. Then you can go to the dashboard section, then you can click select new, then you click import, then you can give a gra- ID of the dashboard. Then if you click load, then you can change the name. Then if you have a specific folder, you can specify that folder. I will put it to dashboard. Then we can select the data source. In our case, our Azure manage Prometheus workspace. Then we'll click import. Then it will import the dashboard for you. So it's very detailed dashboard. You can see a lot of information, very good information about your cluster. Right. Likewise, there are you can import, you can build your uh, uh, own dashboards as well. So, for example, if you want to pick your own dashboard, then click new under the dashboard, then go to the new dashboard. Then you can click add visualization, then select the data source. Then what you have to do is you can use the query builder, or you can use the PromQL to uh, put your query. Then you will see a visualization here. Like for example, if you want to see node CPU total, if you run the query, you can see this as a dashboard, right? So that's how you can build your own dashboards as well. Yeah, so that's that's all for this demo actually. So in this demo, I have explained how the Kubernetes Azure Kubernetes Service will use Azure Monitor Workspace to improve the monitoring and observability of your cluster. Uh, okay, now we have configured our AKS cluster with Azure Prometheus Managed Service, which is Azure Monitor Workspace. And now we can see the metrics and the dashboards in Grafana as well. So now we know that the integration is working as expected. So the metrics and data is ingesting into the Azure Monitor Workspace, and Grafana can uh, get those metrics to view them in the dashboards. Now the next step, what we are going to do is we are going to see how we can use uh, Prometheus alerts to notify a different type of alerts in by using Azure Monitor, right? Uh, if you can remember in our previous in the explanation of the bicep, I have explained that we have separate alert rules configured for Azure Monitor Workspace to notify some critical alerts related to your cluster. So now let's take a look at what are these alerts and how that that alert can be used to trigger uh, notifications in the AKS. So if you go to the cluster, then you can see there's a separate Prometheus rule group, right, for alerts. So if you click that rule group, you can see in the overview we don't have any recording rules because this alert Prometheus alert rule is specific for alerting purpose. So therefore we don't have any recording rules. We only have alerting rules, right? So if you go to the rules, then you can find all the alert rules that are available, right? So here you can see if there are any pod crashing happen, that means if the pod is crash back loop backing, then we have no alerting rule to notify uh, the that pod name and the information. Then there are a lot of other metrics related alerts as well. Then you can find as keep not ready alert. So that means if there's any node within the cluster which is not in the ready state, then this alert will trigger and send a notification to the notification system, right? So let's take a look at one of these alerts. So for example, if I take a look at this node, cube node not ready alert, then you can find the name of the alert, then the severity. So it based on the severity, you can specify the which severity this alert should be. So you have critical error warning information or course. Then this is the most important thing here. This is condition. In the condition, you have expression. Expression is simply another from QL query. So this from QL query is looking for this specific metric called cube node state condition, and it will make sure that the condition is ready and status is equal to 0. So if uh, if this condition is matched, then it will notify you that the information related to the node, right? So then we have a wait for period. That means we can specify how long do you need to wait until this alert is triggered, right? So for example, you can see you can specify wait period as 5, 10. Like there are different time period here, so you can specify that waiting period, because sometimes some alerts will be some alerts will be triggered for a specific moment, and it will uh, auto resolve those incidents, so you don't have to uh, overflow your notification system by sending a lot of alerts that are resolved automatically, right? Then you can specify labels, then annotations. In the action group section, you can include Azure action group, right? So in my case, I have action group which will use email to send notification. So you will receive an email for the specific email address that are configured. In here, you can add multiple adult groups as well. So if you have like a logic app or any other ITSM system configured, so these can be added as well. In advanced option, you can specify do you need to enable this alert, or you need to automatically resolve this alert if the alert is resolved within a specific time period. That is come as the time to auto resolve. So that means within 10 minutes, the alert got resolved, then it automatically resolved the alert. Okay, now let's look at how we can do this in action. So for this, what I'll do is um, I will open my terminal. Then I will go to my Azure portal. Then I will go to the cluster. Then I will get the kube config of my cluster. Then I will get the credential, right? Okay. Now you can see my cluster is there. So if you keep serial get nodes, so you can see I have 2 nodes available in my cluster. Okay, now you can see that I have 2 nodes. So now we'll go and see how we can create pod which is having cashback loopback. So for that, what I'll do is I have specific YAML configuration with me, so I will use that to run a pod, and this pod will be continuously cashback and loopback. So what I'll do is I will use Vim, then I will paste this pod, right? Then I will apply the pod, apply the manifest. Okay, so we'll see. Okay, now you can see that this crashback loop pod is crashback loop happening. So we will see a notification at some point from the cluster, from the Prometheus, complaining that there's a pod is crashback in loopback. But we need to wait some time, because if you go to the alert uh, and see the alert status for cache condition for cashback loopback, you can see that it will wait 15 minutes. So that means it will gather the 15 minutes of data before it will uh, notify to the notification system, which is in my case it is an email, right? So we will wait until that until notification is in trigger. So when the notification is trigger, we will come back and see. Until that crashback loopback is triggered, what we can do is we can trigger another notification alert, right? So what we can do is we can uh, make one of our node unavailable. So we can do it by logging into the node and make it not ready, right? So let's do that and see how it's going to work, right? So what I do is I will use kube get nodes. Then I will select this first node, right? With the node name. Then k node shell. Then paste the node name. Then I will log into the node, right? So now I'm in the node, right? So to trigger to make one of these node not available, what we can do is we can stop the kubelet in the node. So if the kubelet is not working, that means that automatically Kubernetes will identify that the kubelet is not working, so that it will not, the node will uh, change its state to not ready, right? So if I use systemctl, then if I take the status of the kubelet service, you can see the kubelet service is running. So what I can do is I can stop the kubelet. So when you stop the kubelet, your shell will run responsive, because for this shell it is using a pod. So when you stop the kubelet, all the pods will be uh, all the pods will not work. So therefore I have to uh, exit through the control C. Okay. Now if I wait for a few seconds, I hope I can see the kubelet the node status is changed, not ready. So let's take a look at whether it is changed to not ready. Okay, not yet. So we will wait some time and see and come back when the status of the node. This node status has to be changed to the not ready state. Okay, it's after few seconds, the Kubernetes, the node that we stop, the node which we stop the kubelet, the status has changed to not ready. That means this node is in not ready state. So now the Prometheus alerting system will identify this node is in not ready state. Then after that initial wait time, then there will be a alert. There will be a trigger for the alert rule. Then the alert rule will notify with the relevant notification channel. So we'll come back after both of these alerts are triggered, and we'll go through the alerts and see how it is showing in the Azure portal, as well as how you get it as an email. Okay, now you can see that there are few alerts are triggered. So you can see kube pod not ready state alert is triggered, and kube deployment replica mismatch alert is triggered, and kube not ready state alert is triggered. So the first alert, the kube pod not ready state alert is created because of the crashback loopback, so that the pod is not in a ready state for a specific period of time. So you can see the reason in the rule expression as satisfied for over 15 minutes and reach the value of 1 for the following neighbor conditions, right? So here you can see the information, severity, fire time, then affected resource. So you can see it is coming from Prometheus. So then the additional information, you can see the specific alert rule that is triggered and evaluation intervals. So the how much of back time period that looks for, an expression value, then the description as well as other information like alert rule. So if you click this alert rule, then it will open in a new tab with the alert rule. So you can see the specific alert related to this Prometheus alert. So you can see it will open the Prometheus alert group. So you can go and see the rules in the alert group. Then under the history, you can see like information about what's happened. So you can see that specific alert is triggered on this time. Then it will trigger the action group, and the action group will do the notification to the relevant configured targets, right? So then if you take a look at the third alert, which is come as cube node not ready. This happened because of the uh, because we stopped the kubelet on one of these node. So therefore the Kubernetes node become status has changed to not ready. So it evaluate for a specific period of time, and if the value is 0, that means um, the node is not ready state. So therefore it will go and trigger the alert. So you can see in the history as well how the alert is worked. And if I open on my emails, so I can see that the alert notification has triggered, and I got an email from Azure Monitor saying that this pod is not ready, right? So you can see the severity of the alert, then the alert name, then the cluster name, and all the details are available in this email. So you can use the rule ID, so you can go and see them in the portal. then the expression, then all the evaluation time, and the additional label. In the labels, you can see the pod name, namespace, cluster name, and security as well. Now we'll try to auto resolve these alerts. So what I'll go do is I will get the pods and I will delete the pod. Then to make the node available, keep, keep nodes. Okay, now already the node becomes available, right? I think it is replaced from the Azure AKS cluster because of it's not in for a long, it stayed not ready for a specific longer period of time. So it is already created a new node for that. So after few minutes will see that these alerts will be auto resolved and you will get a notification for the resolved as well. Now you can see that there are no alerts because now the alerts are all closed. So if you change this filter to resolve and apply, then you can see that the previous alerts are automatically resolved. Right? So if you click one of these alerts, then you can see the alert condition is resolved. Then if you go to the history, also you can see the alert is marked as resolved in the history as well. So that's how the automatic resolve works. So if that were the alert condition is resolved for a specific period of time, then if you enable the auto resolve option, then it will be automatically resolved. Okay, so that's all for the alert section and the demo for how we can monitor Azure Kubernetes cluster with Azure Monitor Workspace and Grafana. So I hope you guys have learned or got some new information about Azure Monitor Workspace. So I would do another video related to Azure Monitor in future. So it has some additional features that in that video I will explain some additional features that we can configure in Azure Monitor Workspace. In conclusion, we can see that Azure Monitor Workspace is a really good service which will give you very deep insight into your containerized workloads. So it will use Prometheus metrics to give more visibility in your application metrics, and you can build very informative dashboards by using Grafana, and you can do alerts based on the alerting rule in Prometheus. So I highly recommend to anyone who are using Azure Kubernetes Service to integrate Azure Monitor Workspace with their containerized application to get more in-depth visibility into the performance and the metrics of your application. So that's all for this video. Thank you for watching, and Please subscribe if you are not already subscribed. So I will come up with another video in future. Until then, goodbye.